All right, let's implement this solution together. Thank you for sharing your answers. Here we're going to implement a faster version. And I'm going to define it as max sum faster. Even though you are not able to solve this problem, don't worry. I gave you like limited amount of time. So don't worry too much. So what we are going to do is optimize this part. All right. So how can you optimize this part? So rather than having another for loop, what we are going to do is just remove this part and move this sum here. And if you add the next sequence, then that is our current maximal subsum. All right. So we are going to just check if the current sum is maximum subsum. Here we need to change K to J. So that's all we need to do. So this one basically removes one for loop, and removing one for loop enhances the efficiency. All right. So this is our maximum subsum faster version. Any questions about this implementation? Okay, let's move on. Again, we're going to analyze this faster version. Here, we're going to count the number of additions once again. So what is the number of additions in this case? In this case, we're just looping through. This len A is what we call n, and this one is from I to n. So the number of additions here is simply n minus I, right? So that is what comes here. And we are iterating through I from 0 to n minus 1, because this value changes from I to n minus 1. So that is what comes here and here. All right. And when we expand this equation, that is going to be, we just put the value I here from 0 to n minus 1. Then this value becomes n minus 1 plus plus 1. And we know how to evaluate this value, right? This one is simply summing k from 1 to n. And that is n squared plus n over 2. And can you guys remember this number? This is what we just saw in the previous slide here. So we saw that this is the total number of subsequences we need to check, right? And our algorithm here, the faster version, does the addition, and this is exactly the number of possible subsequences, right? And this seems already quite good. We only look at each subsequence just single time. We do not look at each subsequence, all possible cases, more than once, right? And my question here is, can you do even better? And the answer is, amazingly, yes. We can use recursion to improve our solution. So how can you do that? This is another PPP exercise. Think about how we can categorize cases. So in the recursion class, we talked about what is recursion. Recursion is about breaking a big problem into smaller ones, right? So think about how we can categorize some cases and how we can call recursion